So today some fire extinguisher, and let's take a look at this metal detector kit. Or not just to look at it, let's try to build it, test it and explain how does it work. If it does, of course. It was donated to me, so thanks for the donation, and it's basically a kit with a board, some components and this manual or instructions with a schematic, some text in Chinese and the list of components, probably. And the model number is MDS60, metal detector something 60 probably. And here's once more the schematic. And here's the text, which unfortunately is just in Chinese, but if you understand Chinese or if you want to use some optical recognition translator on it, you can. And now let's try to open it and then build it. It's a bag full of components and this board. And the metal detector coil is actually integrated into the board. And it seems to be a double-sided board with coils from both sides. Here is the end of one coil and the other end. And from the other side, here is one end and the other. And the board also has the markings of the components on it, so it's quite easy to assemble. And now let's take a look at the schematic of it, and it seems quite simple. The power comes in here, there is a switch, some decoupling capacitor and some oscillator with a transistor and a double coil. It's a simple oscillator with this main coil switched by the transistor and this feedback coil, putting a positive feedback into its base so it oscillates. And then the signal is amplified by those two transistors probably, and it goes into the speaker and it probably also lights up this LED. And the speaker is this one, and here is the LED. Here is the switch. Here you can see the transistors, some resistors, the terminals for the input voltage, some small ceramic capacitors, an electrolytic capacitor, and that's it. And how does it detect metals? Well, you probably set this potentiometer such a way that the oscillator is just below the threshold where it starts oscillating. And if you put some metal object to it, it probably improves the feedback a little bit and it starts oscillating. The metal object probably sets it just above the threshold for oscillations. And the metal object changes the inductance of the coils, or it improves the coupling between the coils, or it also changes the resonant frequency of this coil with this capacitor. So let's try to assemble it and see how does it behave. And should I record the process of assembly and soldering? Well, I probably should for the beginners, and the others may skip it. Of course, the old recommendation is to put smaller components into the board first and then bigger components. So let's begin with the resistors. There has to be a 2 kilo ohm resistor, and it's this one, red, black, black, brown. The red band means 2, the black bands mean 0, 0, and the brown band means 1 extra 0, so it's 2000 ohms or 2 kilo ohms. And the last band is the tolerance. So let's put this resistor into it. Let's bend the leads or wires and let's put it into the board. And the next resistor is meant to be 200 kilo ohms, and its marking is red, black, black, orange. 2, 0, 0, and orange means another 3 zeros. So it's 200,000 ohms or 200 kilo ohms. So again, let's bend it, let's put it into the board. And the last resistor is yellow, violet, black, black. Yellow means 4, violet means 7, black means 0, and the other black means 0 extra zeros, basically no added zeros, so it's 470 ohms. Let's put it in it, and that's the last resistor in this board. And let's crop the wires. I left just small pieces sticking out and they are bent so it doesn't fall out. you can insert one, solder this one, insert another, solder this one, and so on. Or you can basically insert all and then solder all. Then of course you have to bend the wires so it doesn't fall out. Now let's put the ceramic capacitors into it. This one says 104, which means 10 plus another 4 zeros. The last digit is the number of added zeros, so it's 100,000 picofarads or 100 nanofarads. And that's it. And there is one more capacitor with the same marking, so let's put it here. And of course I cropped the wires and also I bent them such a way that they don't fall out, but also they don't cause a short circuit. Now those small ceramic capacitors, TU, which means 20 TU and another TU zeros, 2200 picofarads or 2.2 nanofarads. And one more with the same value goes here. Now let's put the electrolytic capacitor into the board, this one. And this strip indicates negative and the longer wire means positive. So the longer wire goes into positive and the negative goes into this half of the circle with stripes on it. Now the potentiometer, which goes here, the board says 100 R, which means 100 ohms, and the potentiometer also says 100 ohms. 1 0 and 1, which means another 0, so it's 100 ohms. But the oddity is that the schematic says 1 kilo ohm. Now the question is, which one is right, which one is wrong? But let's try to assemble it with the components that came with this, and let's see if it works or not. Now let's put the switch into it, and this rectangular hole probably is meant to go to this rectangle here on the board. I can actually test it using a conductivity test to see which contacts are normally open. Now it's pressed, now it's out, pressed, out, and the other ones are not connected. So the normally open contacts are here, and it makes sense. They are connected to the connections from the input into the circuitry, and both normally open contacts are in parallel. And now of course let's put the transistors in it according to the marking 9 to 12. So this one goes here, and according to the shape on the board it goes in like this. And the second transistor and the last one goes here. And the LED, it has one side of the circle cut on it here, and it correlates to this marking on the board. And the longer pin is the anode. And on the schematic symbol, the anode is this one and the cathode is this one. So let's put it in this way. And the speaker or buzzer, this one says positive and it also says positive here, and also probably on the speaker it says positive, yes. Let's put it in according to the marking and let's bend it so it doesn't fall out. And of course those screw terminals, and that's it. And now of course let's try to solder it using a horrible way, using my soldering gun. Some rosin, if the rosin in this solder is not enough, and of course 1 kilogram of leaded solder, which hopefully will be enough. And of course I lost my thin soldering wire, so let's use this super thick one, which is a horrible idea, but anyway, let's just simply solder it. Let's put tons of rosin on it, so the solder spreads better, and also with tons of rosin, it has less tendency to make short circuit. With tons of rosin, you can kind of splash the solder over everything and it goes where it should go without making a short circuit, which is an amazing property of the rosin. It makes a short circuit, for example, between all 3 pins of the transistor, and if I put more rosin in it, it no longer makes a short circuit. So let's basically keep splashing the solder on it, and that's it. If you use tons of rosin, you can basically even solder tiny SMD components using a super thick soldering wire and a soldering gun. Basically soldering multiple pins at once. Of course it's not the right way, but it works. Of course way too much solder now. But let's save it using way too much rosin. Of course there is probably a lot of channels explaining how to solder properly, so I don't have to do it. Let's solder horribly, because it's more fun, and it's also easier, and it actually works. So now it's soldered a horrible way, and you could use some solvent to get rid of the rosin, but it's not necessary. The rosin is not conductive, it doesn't cause any short circuit. Now at least from this side of the board it looks nice, and let's remove this, and now let's test it. And I was originally thinking that one coil in the schematic is one side of the board and the other coil is the other side of the board, but it's different. This main coil is basically the entire coil from both sides, except one turn. And this feedback coil is just one turn. Here you can see there is a tab here, which goes to positive, and then it makes just one extra turn around it, and then it goes into the base of the transistor as a feedback. So basically this coil is all turns except one, and this coil is just one turn, which is weird. But anyway, let's test it. The schematic says 3 to 5 volts DC, so let's power it using 3 AAA batteries. Of course you can use a lithium-ion battery, for example 18650, but if something goes horribly wrong, the short circuit of those batteries is smaller. And those are nickel metal hydride. So let's put them into this holder and let's connect it here. The red one is positive, the black one is negative. In total it should be 3.6 volts, which is within the range. And let's tighten it. And let's try to power it now. And it's beeping. Let's turn this. It seems to do something. There is a certain threshold, and above the threshold it's beeping. Let's put it just below the threshold, and let's put some metal to it. And it works! Nice! And a screwdriver. Nice! Some bigger metal. It works. What about aluminium? It's also detected, not just iron. Some aluminium piece, brass, a copper stud, copper pipe, my solder. And of course the sensitivity depends on the potentiometer. If it's set just below the threshold, it can be detected from about 5 centimeters, 6 centimeters. If you set minimum sensitivity, it's just barely 1 centimeter. And this one is now too small for it. Now it's too low sensitivity. Let's increase it. With the maximum sensitivity just below the threshold, it works to about 5 centimeters. 2 centimeters for this. 2.5 for this. 3.5 for this. 2 for a screwdriver. Can a small screw be detected? About 1 centimeter. And a nail? About half a centimeter. And of course the threshold is slightly drifting, but not much. But occasionally you have to retune it. It's a very simple circuit, so there is a slight drift, but nothing horrible. So it doesn't look so bad. Big metal objects can be detected about 5, 6, 7, maybe 8 centimeters away with the maximum sensitivity, and tiny metal objects about half a centimeter away. But of course for the maximum sensitivity you have to set it accurately just below the threshold. And of course the threshold is slightly drifting, so it may occasionally start beeping with no metal object, or it can drift the other way and basically drift to the lower sensitivity. But it works quite nicely given the simplicity of it. And it works with 100 ohm potentiometer, so this marking is probably wrong. And in the list of the components, it's actually right. And I have to say, I didn't actually take a close enough look at the schematic, and I made some assumptions which were not right. I was looking at this oscillator and I thought this is just an audio amplifier, and now I realized it's actually not an audio amplifier. Those 2 transistors are just switches. They are just DC switches. They are just on or off. And the schematic says speaker, but it's actually a self-oscillating buzzer. This one is actually a buzzer with a built-in oscillator, and it beeps when you connect a DC voltage to it. And the clue is that it has this high capacitance electrolytic capacitor connected in parallel to it. So it's not really getting any audible signal at its input. It's getting a DC voltage and it's generating the sound itself. And how does it actually indicate? Well, when the oscillator is oscillating at a high enough amplitude, it periodically turns this transistor on during each negative cycle, and this transistor always discharges this capacitor and keeps this transistor off, and the buzzer is silent. But when the amplitude of the oscillator is not enough to turn this transistor on, it's off, and this capacitor charges via this resistor, and this transistor turns on, and the buzzer produces a sound. So those transistors are simply just switches turning the buzzer on when the amplitude on the oscillator drops. The metal object is kind of a short turn, reducing the feedback to the point where the oscillations disappear because the amplification is less than 1. The higher resistance you set on this potentiometer, the less current you supply into it, and also you basically supply a negative feedback through the emitter of the transistor. And so the higher the resistance, the less likely it is to oscillate. So you basically set it just above the threshold for oscillations, and when you put a metal object to it, it gets below the threshold and the oscillations disappear, or it reduces the amplitude enough so that it no longer turns this transistor on. So the moral of the story is that you should take a closer look at the schematic before making assumptions. And the speaker is not actually a speaker, it's a self-oscillating buzzer. And it buzzes when I connect just the DC voltage to it. And now of course let's connect my oscilloscope to this main coil. And you can see the oscillations, which are 258 kHz, which is way too high to be audible. It's not what you hear from the buzzer. Let's try to zoom it. And it's a nice sine wave actually. And when you put some metal to it, it disturbs the oscillator and the amplitude goes down. And this amplitude reduction is detected, and this actually turns on the buzzer. And if I turn the potentiometer, setting a lower sensitivity actually increases the amplitude, so the metal object is less likely to disturb the oscillations. When I reduce the amplitude, at some point the amplitude is too low to keep turning this transistor on, so it no longer keeps this one off and the buzzer activates. And of course there are several different types of metal detectors. This one is very simple. The metal object just breaks the oscillations in a simple oscillator. Some better metal detectors can tell different metals apart. And how much does it draw from the battery? 3.5 milliamps when it's not buzzing, and about 40 milliamps when it's buzzing. And of course an analog oscilloscope, which may bring some extra observations. When putting the metal to it, the oscillations are kind of irregular. And when I reduce the sensitivity using the potentiometer, the amplitude goes up and it's distorted here. And it's basically the emitter to base junction of this transistor in its forward direction, clamping the amplitude on it. So this is diagnosed, and see you in my next videos. And thanks to all of my patrons on Patreon. I really appreciate your support. And of course you can also become my patron to support my channel and get early videos. The link to my Patreon is in the description, as well as the link to my Instagram. And I also plan to build another type of a metal detector.